Hello, everyone, and today we're going to be looking at the periodic table and the atomic mass of the elements. So, your LEQ for today is what are isotopes and why is the atomic mass a decimal number on the periodic table? Our standard that we're looking at today is 8P12. So in your input section, I want you to answer these two questions. Why is the atomic mass of an element written in decimal form? And are there any that are not in decimal form? So here is a picture of the periodic table, and by now you've seen a couple different versions of the periodic table. You can see here this one is a traditional one with the atomic number, the symbol, element name, and the atomic mass. It is also color coded to see what family each of the elements belong to. Remember that the period is going to be labeled as each row so you can see that there are 7 periods on the periodic table, and the group number is at the very top of the periodic table, which there are 18 groups. Today, we will explore a new element that Miss Stone and I just discovered. Isn't that exciting? It is called Boxium, and the symbol for Boxium that we're going to use today is BX. We're going to view this video as a demonstration to understand isotopes, and you're going to complete this in your notebook. So in front of me, I have the nucleus of Boxium, okay? And so this box right here is going to represent the nucleus. What is inside of the nucleus of Boxium? If you said beads, you're kind of correct. But those beads are going to represent the protons, which are purple, and neutrons, okay, which are going to be clear. So protons and neutrons inside the nucleus of Boxium. Go ahead and create this chart in your notes right underneath your input section. We're going to use this chart throughout the lesson, so you'll be filling in these blanks. This is what your notebook is eventually going to look like without the blanks. And you can see that I have created the table right underneath my input. So when we look at this information for our shorthand key for Boxium, we can see that the mass number is at top, 15. The atomic number is 7, and we have our chemical symbol here, which is BX. So let's think about this for a second. We have the mass number 15, the atomic number of 7. So how many protons are in Boxium, in the nucleus of Boxium? Now, how many neutrons are in the nucleus of Boxium? If you said the atomic number equals the number of protons, so if the atomic number is 7, then proton number is also 7. What about the neutrons? If we use the strategy APE man stands for mass minus atomic number equals neutrons. So the mass is 15 minus the atomic number of 7 equals 8 as your neutrons. So you can fill out this chart. This is our first isotope that we're going to look at today, our first element. So when we say isotope, what we mean by that is that it is the same atom, but with a different number of neutrons. So that's why it was so important for you to understand how to calculate neutrons, because for the same type of atom, there could be a different number of neutrons. Let's see how that works. So if we look at carbon on the periodic table, and I apologize for this blurriness, but carbon on the periodic table, we can see the atomic number is 6 and the mass number is 12.011. And here's that decimal that we were talking about at the very beginning. So when we calculate the number of neutrons for carbon that is represented on the periodic table, we take the atomic mass, which is 12.011, we round that to 12. 12 minus the atomic number, which is 6. 12 minus 6 equals 6. So there are 6 neutrons represented by this element here, this isotope, we're going to call it. But if we look at our example, carbon 14 is going to represent the mass number. Here it says that you can write the isotope as the element followed by a dash and the isotope's mass number. So if we were looking at just the periodic table, it will be carbon dash 12. But here it says carbon dash 14. 14 represents the mass number. So if we were trying to figure out how many neutrons carbon 14 had, we would say 14 minus 6. 6 has to stay the same because that is the atomic number and the number of protons. If you change the number of protons, you change the element completely. Okay, so 14 minus 6 equals 8. So there are 8 neutrons in carbon 14, whereas there are only 6 neutrons in carbon 12. That's just an example, and you're going to see what we're talking about when we call these elements isotopes when we do our demonstration. So isotopes of an element do not occur on Earth with the same frequency. So that means that there isn't going to be the same number of that isotope that exists on Earth. So if we look at the example, 92, there could be 92% of lithium atoms that are lithium 6, lithium with a mass of 6, but only 8% of lithium 7, lithium with a mass of 7. So it's just not going to occur evenly throughout, or when it occurs or when you see it on Earth. Natural abundance is the percentage of one isotope of an atom that occurs naturally on Earth. And so this is going to be an estimate of all the isotopes that are known on Earth. Just an estimate. Because the unit of mass of atoms are so small, we're going to use the unit AMU, which stands for atomic mass unit. So let's go back to our original question. Why is the atomic mass on the periodic table in decimal form? Well, it's going to be the weighted mass of all the isotopes for that element. So remember, isotopes are going to be the same element or the same type of atom, but it has a different number of neutrons. So when we look at that, if one element, if the element carbon has a different number of neutrons, we can see that the mass number changes. So we're going to take the average mass of all the elements, isotopes that exist on Earth, and also take account for the percentage of how much of each of the isotopes exists for that sample. So let's think about this. If we ask on a quiz or a test why the atomic number, the atomic mass is a decimal form on the periodic table, are you going to tell us that the electrons add a little bit more mass? What about if we say that the protons and neutrons are going to be the only parts of the protons and neutrons are in the nucleus? Is that the right answer? What about if we say that chemists have very precise equipment and that's how they measure out the mass and they put it in decimal form? Is that the correct answer? No. So when we look at the mass number, remember protons and neutrons are equal to 1 AMU. So it's always going to be a whole number for the mass of an element. The reason why the weighted mass of isotopes are going to be in decimal form on the periodic table is because we're looking at the average mass of all the isotopes that exist on Earth. So let's look at the isotopes of boxium. Remember that our original boxium atom had 7 protons and 8 neutrons, okay? So let's look at isotope number 2. Isotope number 2 is represented here in this clear box. This is still boxium. We have the atomic number as 7. So in my nucleus of boxium, there are 7 protons. 1, 2, 3, 4, 5, 6, 7. 7 purple. The atomic mass we see in our shorthand here that you're going to write in your notebook is 12. So how many neutrons does the number 2 isotope of boxium have? If you said 5, that is correct. There are 7 protons and 5 neutrons in the isotope of boxium, in the second isotope of boxium. Let's move on to our pink. This is still boxium. I have the nucleus of boxium. Inside my nucleus, there are 7 purple beads, which represent the protons. 7. The atomic mass of the third isotope is 14. How many neutrons do we have in isotope 3? If you said 7, that is correct. 14 minus 7 equals 7. Let's look at the next isotope in our red container. I have 1, 2, 3, 4, 5, 6, 7. 7 protons in my nucleus. The atomic mass of boxium, of the fourth isotope of boxium, is 17. So all together, I have 17 in here. What is the number of neutrons? If you said 10, you are correct. 17 minus 10, 17 minus 7 equals 10. So 17 as the mass, 7 as the atomic number, and that is going to equal 10 for the number of neutrons. If we move on to isotope 5, you tell me this time. Isotope 5, what is the atomic number? What if you said 7? That is correct. Number of protons. If you said 7, that is correct. The mass number. If you said the mass number of isotope 5 is 20, you are correct. How many neutrons does isotope 5 of boxium have? If you said 13, you are correct. The atomic mass is 20 minus the atomic number of 7 equals 13. Now what we need for you to do is answer these questions in complete sentences based on the data. According to your data, are all the boxes the same element? And how do you know? What do you call atoms that have the same number of protons but a different number of neutrons? And number 3, other than the number of neutrons and color, name one thing that is different between the atoms of boxium. I hope we gave you a clear understanding of what isotopes are and how they are different. See you next time.